Hello students, welcome to chemistry class. Today's video is a board booster session on electrochemistry of class 12. Very important from HSC Maharashtra board exam. In this video, we are going to cover important definitions, theory questions, numerical step by step, and board oriented answer which you can write directly in exam. So students, keep your notebook ready. Let us start with some important theory questions that is related to board exam. Our first theory question from this chapter will be state Kohlrausch law and write the mathematical expression for molar conductivity at infinite dilution and write its application. So the answer for the above question is, it states that at infinite dilution, the molar conductivity of an electrolyte is equal to the sum of the molar ionic conductivities of its constituent ion, each multiplied by number of ion produced. The mathematical equation for the molar conductivity, as you can see on your screen, where n plus and n minus are number of moles of cation in an ion, and lambda plus and lambda minus are molar conductivities of cation in an ion. The above equation is used to calculate the molar conductivity of weak electrolyte at infinite dilution. For example, molar conductivity of calcium chloride and potassium chloride at zero concentration, as you can see in your screen. Let us discuss now second question related to theory is, write the cell reaction occurring in lead storage battery during discharge. Answer for the above question is, lead accumulators store electrical energy due to regeneration of original reactants during recharging. It functions as galvanic cell and as electrolytic cell well. With the help of schematic diagram, we will come to know what lead storage battery contains. A group of lead plates serves as anode and another group of lead plates bearing lead dioxide serves as cathode. These electrodes are dipped in electrolyte of aqueous solution of sulfuric acid. Let us see now the reaction involved in lead storage battery during discharge. At anode, lead plates are reacting with sulfate ions to form lead sulfate by removing 2 electrons. The same 2 electrons are captured at cathode, where lead oxide is combining with sulfate ion to form lead sulfate. The net cell reaction is the sum of overall oxidation at anode and overall reduction at cathode. As the cell operates to generate current, sulfuric acid is consumed, its concentration decreases, and the cell potential is decreases. The third and important question is, draw a neat and labeled diagram of H2O2 fuel cell, write 2 applications of fuel cell and write cell reaction involved in it. Let us focus on the answers now. The function of fuel cell is based on the fact that combustion reactions are of redox type and can use to regenerate electricity. Fuel used in this cell is hydrogen gas. The anode and cathodes are porous carbon rods containing small amount of platinum metal, and the electrolyte is hot aqueous solution of potassium hydroxide. At the anode, hydrogen gas is oxidized and 4 electrons are released. Also at cathode, oxygen is reduced, react with 2 water molecule and 4 electrons to produce 4 hydroxide ion. In the overall cell reaction, hydrogen and oxygens are combined to form water and electrical energy. This type of fuel cells are used in automobiles and for electrical power in space program. Last but not the least theory question is, define reference electrode, write functions of salt bridge, draw a neat and labeled diagram of standard hydrogen electrode. Let us focus with the answers. A reference electrode is an electrode having a constant and known electrode potential used for measure the electrode potential of other electrodes. And as for functions of salt bridge maintain electrical neutrality in electrochemical cell, complete the electrical circuit by allowing ions to migrate, and prevents direct mixing of electrolyte solution. And for the diagram, you can use textual representation for SHE electrode. Let us focus on important definitions from this chapter. First and foremost, definition of electrochemical cell. An electrochemical cell is a device in which chemical energy is converted into electrical energy by a redox reaction occurring between two electrodes dipped in an electrolyte. Secondly, definition for EMF of a cell. The electromotive force of a cell is a maximum potential difference between two electrodes of the cell when no current is flowing in the circuit. Next is single electrode potential. The single electrode potential is a potential difference developed between an electrode and the electrolyte when the electrode is immersed in a solution of its own ion. Next definition is definition for molar conductance. It is the conductance of all ion produced by 1 mole of an electrolyte when placed between two electrons 1 centimeter apart. Next is electrochemical series. The series is an arrangement of elements or ions in increasing order of their standard potentials. Last but not the least, definition for specific conductance. It is the conductance of a solution of unit length and unit cross-sectional area, and it is the reciprocal of resistivity. With this, we have discussed almost 6 important definitions from this chapter. Let us now focus on type of electrochemical cell. We know electrochemical cells are classified as electrolytic cell and galvanic cell. Electrolytic cell involve a non-spontaneous redox reaction by applying an external electrical current. For example, electrolysis of water or electrolysis of molten sodium chloride. Also, for the galvanic cell, electricity is generated through the use of spontaneous chemical reaction. For example, Daniell cell. The diagram displayed on the screen represents both the electrochemical cells. Now we will focus on how to write cell representation for electrolytic cell and galvanic cell. In electrolytic cell, anode is positive and cathode is negative, that is opposite of galvanic cell. Electrodes used in this cell is platinum connected to positive where oxidation occur and negative where reduction occur, and both the electrodes are dipped in same electrolyte. And for the galvanic cell, we use two different electrodes for anode and cathode. On the left side, zinc electrodes is dipped in zinc solution, and on the right hand side, copper electrode is dipped in copper solution. Both the electrolytes are connected with the salt bridge, and the representation for salt bridge is double vertical line. Students, based on the questions frequently asked in the Maharashtra board examination, I have selected a few important formula for you. Please make a note of these formula along with their correct units. Units in numericals are very important because even if the numerical value is correct, wrong or missing unit can lead to loss of marks. Now, we shall proceed to the step-by-step solutions of numericals from this chapter. The first numerical is on standard EMF of the cell. The EMF of the given cell and standard potential of silver electrode are given. We have to find the potential of copper electrode. Read the numerical carefully and write down the given from the numerical. We know that standard cell potential is given by the formula E naught of cell equals to E naught of cathode minus E naught of anode. As silver has higher reduction potential, hence it acts as cathode and copper acts as anode. On rearranging and substituting the above value, we can calculate E naught of anode. For the second type of numerical, we need to write cell reaction and calculate E naught of the given electrochemical cell. In the step 1, we have to identify anode and cathode. The electrode with more negative reduction potential acts as anode, as we have discussed in our previous numerical. Here, aluminium has more negative potential, therefore aluminium is the anode and zinc is cathode. After that, write the half cell reactions of each electrode. At anode, aluminium is oxidized to aluminium plus 3, and at cathode, zinc ion get reduced to zinc solid. As we have seen, the above reaction is not balanced. So we need to balance in terms of electron and write the overall cell reaction. In order to obtain balanced half cell reactions, the anode half cell is multiplied by 2, whereas the cathode half cell is multiplied by 3. By cancelling 6 electrons from the anode and cathode half cell reactions, the overall cell reaction is obtained. Hence, from the standard electrode potential equation, the value of E naught of the cell is calculated by substituting the standard electrode potential values. Let us solve the question number 3. In this, we need to calculate degree of dissociation and dissociation constant of 0.01 molar solution. The molar conductivity of acetic acid at given temperature and at zero concentration is given. By reading the numerical, let us write the given data. Since we know acetic acid is a weak electrolyte, the degree of dissociation is given by the formula lambda m upon lambda naught. By substituting the value, we can get the answer of 0.045. Since in the board exam we cannot use calculator, so we can focus on using log books to solve the numericals. First, convert the formula into log form and substitute the value to obtain a negative number. While calculating the antilog, the negative number must convert it into bar number by subtracting by 1. And with the bar number, you can calculate the antilog using your log book. In this step 2, by knowing the degree of dissociation formula, we can calculate the dissociation constant for acetic acid. Since acetic acid is a weak acid, its dissociation constant is given by the relation Ka equals to C alpha square. By substituting the given values, the dissociation constant of acetic acid is calculated as 2.025 into 10 raised to minus 5. The same value we can obtain using logarithm equation. Please make a note that degree of dissociation and dissociation constant are unitless quantities, and always show log steps clearly to get full marks in numericals. Let us move to the next question. In this numerical, the resistance of 0.01 molar KCl solution is given as 640 ohms. Using the same conductivity cell, a 0.001 molar silver nitrate solution shows resistance of 6530 ohms. Calculate molar conductivity of silver nitrate. While reading the above numerical, we can write the given values of 0.01 molar KCl and 0.001 molar silver nitrate solution. By knowing the formula for molar conductivity and cell constants, first we can calculate cell constant using KCl solution. To calculate cell constant, we have conductivity and resistance of KCl. By substituting the values, we obtain cell constant for given cell. This cell constants will remain the same for all solution in the same cell. Now we calculate the specific conductivity of silver nitride solution. Using the cell constant formula, the specific conductivities of silver nitrate solution is calculated. By substituting the given values, the specific conductivity is obtained as 138.2 ohm inverse mole inverse. The same value can also be calculated using logarithm equations. Students, remember that for antilog of a bar number, first express it as 10 to the negative power and then find the antilog of the remaining part. After finding the specific conductivity of silver nitrate, we calculate its molar conductivity using the formula. After substituting the values, the molar conductivity is obtained as 138.2 ohm inverse mole inverse. Now, I have one task for you. Calculate the molar conductivity using the logarithm method. If you get the same value, mention in the comment section that the correct value is obtained. Now let us solve the last numerical based on electrochemistry. Based on the numerical, the molar ionic conductivity of calcium, chloride, sodium and sulfate ions are already given. As we know from Kohlrausch law, at infinite dilution, molar conductivity of an electrolyte is equal to the sum of molar ionic conductivity of its constituent ions. Using the Kohlrausch law formula, we can solve the above numerical. Firstly, we need to calculate molar conductivity of calcium chloride, as calcium chloride dissociate as calcium and chloride ions. So using the formula, you can calculate the molar conductivity of calcium chloride as 256.8 ohm inverse centimeter square mole inverse. Please try to solve the above value using log. Similarly, sodium sulfate dissociates into 2 moles of sodium ions and 1 moles of sulfate ion. By applying Kohlrausch law and substituting the given values, the required value is obtained as 259.8 ohm inverse centimeter square mole inverse. Students are requested to solve this numerical using the logarithm method and mention in the comment section whether the same answer is obtained. I hope this video has given you a basic idea of the electrochemistry chapter from the board point of view. Thank you for watching. Stay tuned for more videos like this.